Lesson 4.2. Graph quadratic functions in vertex or intercept form. Vertex form is first, and as the name implies, it gives the vertex. It's y equals a x minus h squared plus k, where h comma k is the vertex, hence the name vertex form. The A is the same as the A in standard form. It tells whether it opens up or down or how wide or narrow it is. X equals h, which goes through the vertex, is the axis of symmetry. HK is the vertex because if h and k are both 0, our equation would simply be y equals ax squared. And the vertex of that is 0, 0. It's negative b over 2a. b is 0. So 0, negative 0 over 2 times a, 0. Before, we learned that h is how far the graph moves to the right, and k is how far it moves up. So if I move to the right from 0, say I move to the right 4 from 0, I'd be at 4. If I went up 2 from 0, I'd be at 2. So I'd be 4, 2. Just be the h and the k. So if I move right h and then up k from 0, 0, my point will be at h, k. So that's where the vertex is, h, k. Graph these the same way as before. So you find the vertex first, then make a table. Make sure you're graphing at least 5 points. So our first example, just graph this. If we compare it to our vertex form, and I know it's vertex form because it's the parentheses with x minus 1 squared, that's our clue that it's vertex form. You can see that the a is 2, h is 1, and k is 3. So our vertex hk is 1, 3. Make a table with x equals 1 in the middle and plot the points. I used my calculator to make the table. I only see 3 points here. The rest are way off my graph, so I'll do my best to make a nice parabola through those 3 points. If possible, use 5. Intercept form gives you the x-intercepts. It's y equals a x minus p times x minus q, where p and q are the x-intercepts. A is still the leading coefficient and tells you whether it opens up or down or how wide or narrow your graph is. The axis of symmetry is halfway between p and q. So you'd add p and q and divide by 2 to get the halfway point. Graph the intercepts to find the axis and find the axis of symmetry. Make a table using the axis of symmetry in the middle. The vertex will be the x-coordinate, but the vertex is the axis of symmetry. So you plug that into your equation and you find the y-coordinate. So I know we are in intercept form because I have 2 sets of parentheses with x minus or plus a number. So I compare it to intercept form, and I can see that a is going to be 1, p will be 3, and q will be negative 1. The x-intercepts are p and q, which are 3 and negative 1. The vertex is halfway between them, so find the average. Add them together and divide by 2. You get x equals 1. Make a table with x equals 1 in the center. Here's my table. X equals 1 is in the middle. You can plug it in to find the y value. We have all those. Plot the points. Ooh, This time I actually have 7 points graphed. Draw a nice parabola, and there you are. Let's try a word problem. If an object is propelled straight upward from Earth at an initial velocity of 80 feet per second, its height after t seconds is given by that function. How many seconds after it is propelled will the object hit the ground? First of all, we should decide whether we are in vertex form, intercept form, or standard form. Notice the t's are separate, they're not squared. The only form that was like that was intercept form. This is like t minus 0 times t minus 5. So it's an intercept form. If I rewrite the t as t minus 0, we can see that the x-intercepts are 0 and 5. Thus, it'll be at 0 height at the x-intercepts. It'll be on the ground at the x-intercepts, which are 0 and 5 seconds. Choose the answer that makes sense. It was launched at 0 seconds, so it hit the ground at 5 seconds. What is the object's maximum height? Well, as we learned before, that occurs at the vertex. The vertex is halfway between the x-intercepts. So halfway between 0 and 5 is 2.5. Plug this into our function to get the height. So plug the 2.5 for the t, and we get 100 feet. So the maximum height will be 100 feet. Just a refresher on how to multiply a FOIL. To multiply these, you multiply the firsts, x times x gets x squared. Then the outers, negative 3x. Then the inners, 2 times x. And lasts, 2 times the negative 3, which gives us negative 6. And you see the first letters here, the first, outers, inner, last, spells FOIL. That's why we call it the FOIL method. It's really just the distributive property. Combine those together, combine like terms, and you get your result. So then to multiply x minus 2 squared, squaring means you multiply it by itself. So it's x minus 2 times x minus 2. FOIL. So the firsts are x times x. The outers are negative 2x. The inners are negative 2x. And the lasts are negative 2 times negative 2. Gives us x squared minus 4x plus 4. So to write a quadratic function in standard form, I'm going to take that and we're going to multiply it out. So FOIL. First, outers, inners, lasts. The first is x times x. Outers are x times negative 7. The inners are negative 2 times x. And the last was negative 2 times negative 7. Next, combine like terms. And then distribute the negative. So distribute the negative to each part. And now it's in standard form. Let's do it for this one, which is in vertex form. Remember, x plus 2 squared means it's multiplied by itself. So I rewrite my function this way. So instead of being x plus 2 squared, it's x plus 2 times x plus 2. FOIL. First, outers, inners, lasts. The first are x times x. Outers were x times 2. Inners were 2 times x. And the last were 2 times 2. Combine like terms. Distribute the negative. And then negative 4 plus 4 adds up to 0. And there we have it. Here's your assignment. Enjoy it. Have a good day.